Okay, so let's go over the addition and subtraction of vectors. And we have two vectors here that we're going to add and subtract so we get the general idea of it, and then we'll play with like a parallelogram with some diagonals and how we can use the addition and subtraction of vectors to show resultant vectors. So in the first case, let's talk about addition of vectors. Let's say a question asks us to take vector A and we want the addition of vector B. We want to find a resultant vector. Now, a lot of times when we talk about vectors, you'll sometimes see this. And this deals with the magnitude. So that'll actually be the speed they're traveling at, what force there is to it. And in this one, we have nothing. Okay, they've given us no magnitude. All we're doing is just simply finding a resultant vector. If they'd given this, there'd be a different type of question. They're actually looking for a value in terms of the resultant vector. So we're just adding these two vectors together. And there's a couple methods. One of the easiest methods to use is to take, I'm going to just change these into cloners so we can kind of, oops. So we kind of see this, is to take the first vector and then add the second. So the first question asks us to take vector A. So we take vector A, okay, and we set it up. Let's say this is our starting point here. We take vector A, and then we simply add vector B to it. So we take the tail of vector B and add it to the tip of vector A, okay? So this being the tip of vector A, call this guy A, and we take the tail of vector B, we add it to the tip. Okay. So now that we've done this, our resultant vector is actually from the tail of the vector A, and I guess I should write in that the other one's vector B, to the tip of our new vector B. So in other words, our resultant vector is this distance here. And we'll actually use a line, we'll change it to red. Our resultant vector, and because we haven't given it a name, it can technically be vector A plus B. This is vector A plus vector B. This is our resultant vector, the red one in this case. I think there's another method they use sometimes for this too. Tip to tail. That's usually the most common one. Yeah, and that's what we'll go with. Okay. If we're going to subtract the vectors, let's say we have the same two vectors we're going to work with, but in this case we're going to take vector A and subtract vector B. You can kind of see this, okay, and you keep this an idea, is anytime we have a negative in front of the vector, essentially the direction of the vector is the opposite direction, okay? The idea that if we had vector A minus vector A, we have a vector doing this, and another vector that's parallel but in the opposite direction, they nullify each other. This would essentially be 0. Mathematically, that makes sense, okay? So what we can do is we can start off the exact same way. Think of this like we have positive vector A. So I'm going to take the positive vector A, and we're going to start it off the same way we started the addition of vectors. Okay. I'll put it out here, just so we have room. Here's our vector A. Now, what I'm going to do now is you could almost think of this like I've decomposed the question. You can almost think of it like vector A, and everything we'll do is the addition of negative vector B. Okay, so same thing now, I have to find negative vector B. Well, the negative vector B, okay, is I'm going to take the exact same vector we had, oops, but I'm going to flip it around. I guess I can't do that in this case. I'm just going to write a tip at the other end, okay, and we'll group it. So this is now our negative vector B, okay? It's parallel to what we were doing before, but going in the opposite direction. So as I take this, group it all together, as I take this vector, I do the same method as before. I take the tail of it, okay, and attach it to the tip of vector A. So this now being our negative of vector B, I do the exact same process I did before. I go from the tail of vector A to the tip of vector B. And let's do it in red. Beautiful. Okay, and our new resultant vector is very different from our addition of the two vectors. This is vector A minus vector B, okay? And let's say we had a similar question, okay? Let's say I change the order of them. Let's see if our resultant vectors change in this case. Let's say I decide to go vector B plus vector A, okay? I start with the exact same procedure, except I start with the different vector this time. I'll start with vector B. So I'm going to start with our addition question in the exact same spot, okay? This is being our vector b, I've just taken it, and I add vector a to it, and is there a difference in our resultant vector?
No.
No, it's the exact same thing. So it actually didn't matter the order I put those in. Let's take a look on subtraction, if there's any change. Okay, let's say we had negative vector b. Actually, sorry, let's rewrite that. Let's say we have vector b minus vector a. Okay, so in this case, we're working with different vectors. Okay, I have my vector. Where is it? Oh, my vector b. Okay, sorry, that's not what I wanted. There you go. I take my vector b. Okay, so this is our original positive vector b. Okay, so we'll write this in black here, vector b. And the same idea as before, I'm going to take vector a, but I'm just going to change the direction it's going in. I'm going to make this, in order to make it negative vector a, this now becomes the tail and this becomes the tip. So I'll group this all together. Now we can move it easily. And let's apply it with the same strategy we had done before. So we take this guy. Okay. And our new resultant vector, okay, is this, from our tail to our tip. Okay. Now, this being our tail and this being our tip. Remember, this resultant vector was going in that direction, while this one here ends up in the opposite direction of what we had. Mm-hmm. Okay. So what ends up happening is our b subtract a gives a resultant vector that would be a magnitude that's the same, but our directions are opposite of what this one would be. Okay, so with subtraction, we get a little bit of a different vector, essentially same magnitude, but opposite direction. So it's very important which one we have first and which we had second. If we had just changed the order of the two, so I'd start it with, and I'll infinite clone this. If I'd start it with vector b, or negative vector b, so I guess I'll write this in a different color here. Sorry, we're kind of all over the place. Let's say I'd start with negative vector b plus positive vector a. That's the same vectors. I take my vector b, okay, and my positive vector a, which is this guy here, and we end up with the same resultant vector we had in the first place, okay? And that's because in this case, b is still the negative vector, and a is still a positive vector. Where in this one, b is a positive vector and a is a negative, like we said, an opposite type vector. Does that make sense?
Yeah.
Okay.